Okay, to start us off really quickly, what is one AV opinion that you all have that no one would agree with or is like kind of out there?
Well, my opinion is quite obvious, just like Rensha had mentioned, that I really don't think the AV will remove maps in any time soon. It would always be there, it would gonna be there, and I don't think it's going anywhere anytime soon.
Before we move on, can we really quickly move around so you're seated with your pictures? I'm sorry, I didn't think about that. And it would be less confusing for the audience. Sorry about that. You want to go next, Anu?
I mean, can you repeat the question, please? I just.
Yeah, one AV opinion that no one agrees with or that's like out there.
Okay, so hi everyone, I am Anubhav. So what I would like to say is, I mean, many people think that AV, like if we have AVs around there, they are going to be stealing some jobs or something like that. But I don't feel that it's going to be there because it's another autonomy in place, and probably like it's going to be creating different set of employment opportunities, but uh, not necessarily that it's gonna be just totally like driving around and will have no dependence on humans. So that's what I assume.
I'm trying to think of a good one. I guess kind of a broader sense is I spent the last 10 years thinking about cars every single day. And I also really, really dislike cars and don't think cars should exist at the same time. So I don't know, yeah, I don't know how that blends into the AV space, but I guess mostly I just don't want them to drive on me or drive on other people. And so, yeah, take that how you will.
Yeah, for me, I would say I had a conversation with my boss when he mentioned that you need to really believe in where the future of autonomous vehicles will go with safety concerns. I guess from my own perspective, like, well, yeah, this is why they hired me for Zoox autonomy testing, make sure that it's safe. Um, I think there is still a great future for it, especially if you get into a Waymo, it's an awesome ride. So that's just from what my boss had brought in. That's my perspective.
Thank you. Since you all have worked on AVs for long, you must have thought about them quite a lot, I imagine. How do you think our cities will change as AVs develop? What is one thing you're excited about or you think will change drastically? Whoever wants to go first.
Yeah, in my opinion, I would think that one thing that might change is a lot less accidents. At first, maybe more, but eventually we get less and less and less because all those corner cases, special cases, it's been taken care of, it's been developed, it's been investigated, and so on and so forth, and that would be my take on it.
Yeah, I can agree with Simon on this because I mean recently I was actually um, watching a podcast from Drago from Waymo, and they also mentioned some figures around that they have actually, based on the miles that Waymo has driven, uh, or probably, I mean, Waymo represents any autonomous driving in future anyways, not just Waymo, so they have kind of reduced the accidents that are happening around 80 to 82% that are they, those are the figures that they have reported. So, and this is and this is relative to what the number of hazardous incidents that might happen when humans are driving. So this is something that I would like to add as statistical figures that probably that could be changing in near future.
Yeah, I guess I kind of like hope it ends up in that utopian state where it's just a safer place for everybody and pedestrians are kind of like at the forefront of cities and like the first thought about how cities are built. And I hope that autonomous vehicles kind of enable that and just kind of make cities kind of more people-centric instead of car-centric. That's I hope it ends up.
Yeah, I do agree with Kobe here. Very much on what autonomous vehicles can do for future city planning, creating smart cities. I think that will be definitely, even today there's still a clash on wanting to drive your own personal vehicle and then also wanting to go outside of fully autonomous. I think that'll be complex. People like driving.
Thank you so much. So let's now get into the tech stack that we have. I think a slide for this. Okay, so we have four kind of main things that go into AVs. There's mapping, there's perception, there's prediction and planning. And you guys are sitting in a way that Simon is working on mapping and Anubhav is working on perception and prediction and planning. You guys are kind of working on simulations and testing. So let's go one by one. Do you want to tell us, Simon, like what are HD maps? Why do you think they're so important? What goes into them?
Thank you, by the way. But I do think that's one very critical piece is missing, is mapping and localization.
Right.
Localization is an essential part of those pieces. So let's start with the mapping. What is mapping for HD map, for AV? So traditional mapping is more like Google Map, Apple Map, or whatever, so on and so forth. So you do have the information about where you want to go, where the infrastructures are, so on and so forth. So what is map for AV? And how do AV sees the world? And that's mapping. The maps are very, very accurate. They're down to centimeters. And oftentimes, 5 to 7 marginal error. Sometimes maybe L2 is around 5 to 10, so on and so forth. But everything you see on the road is being mapped, localized, down to the centimeters. A stop sign, a traffic light, a camera, so on and so forth. All of that is being mapped into this HD map. And not only you get to know how where this road is, but how many lanes are in this road. Where are the lane markings? Where are the stop sign marking? Where are the stop sign lines? Where are the all this other essential information the AV needs to make decision on? Is being mapped and it's being created and it's being maintained by teams and teams of people that which I'm responsible for to down to the accuracy that is very, very precise. Oftentimes we use LiDAR, IMU, cameras, radar, so on and so forth. All of this contribute to making the HD map. And there are very different HD map between L4 to L2 and L3. So that's HD map. But what is localization? Localization is taking all those information and put the vehicle down to a centimeter accuracy where this vehicle is at all time. Sometimes without GPS coverage, sometimes with nearly very few informations. And there are a number of ways to localize the vehicle. And the map is pretty much one of the essential part of it that has to be there in many, many edge cases, special cases. That is one of the reasons I believe truly that HD map is so essential to AV map, and also it's quite irreplaceable, and we cannot get rid of it just because we don't want it, just because it is expensive or we don't like it. It's just it has to be there in order for our safety, and that would be kind of wraps up what HD map and localization is for for AV map industries.
Can you very briefly go over L3 versus L4? A lot of people in the audience might not know about that. Just one-liners, like what is the difference between them?
I think in order for in terms of mapping and localization, just one word: accuracy. L4 require a lot higher accuracy, a lot less tolerance for that marginal error. It has to be down to 2, 3, maybe up to 5 centimeters at the most. Anything more than that is unacceptable. We cannot accept that that piece of map is a HD map for L4. But whereas L2, things can be a lot less detailed. What I mentioned earlier, we don't necessarily have to know where the traffic light at all time, down to the centimeter. We just know the traffic light is there. It's somewhere in the northwest corner or whatever. And the marking and the road, the non-drivable surface, it can be have much higher marginal error, up to 10 centimeters, 20 centimeters, so on and so forth. It kind of depends on how advanced the AV stack is, and then the HD map had to compromise all those stacks.
So for context, there's like two schools of thought within the AV development. There's one that's like very mapping heavy, which is what Simon is talking about. But there's another school of thought that focuses on end-to-end driving systems, which basically means you're making, like, let's say ChatGPT drive a car. If like it's good enough to like take in video and you just let him make the decisions, let it make the decisions, and then you essentially like let an LLM drive. So I'm curious about Anubhav and you, Kobi. You worked on perception, you work on simulations. What do you think? Do you think perceptions are good enough that maybe in 10 years a car could drive without an HD map and we could have end-to-end systems? And do you think simulations are good enough that we could not need an HD map in the future? You can go, one by one about what your expertise is.
Yeah, that's an interesting question. First of all, I've been working on the last part of it, or probably the second prediction and planning a little bit more than the perception. But I would still like to get have more insights on all of the three aspects to actually cover the end-to-end driving, and then probably I can try to touch base upon what the point that Ramsha mentioned about have ChatGPT drive the car. I just to get to know the audience, how many do we have probably a difference between like what do we mean by perception and what do we mean by sensing? So they are kind of interchangeable terms many a times, but in our autonomous driving industry, sensing is just like you just collect the data. That's like or different sensors that are there, and perception is all about what are we doing with that data. So we can have an n number of sensors like camera for vision, we have radars, we have lidars, we have n number of sensors like collecting data. But then what we do about that data is like, can we detect pedestrian? Can we detect different agents? And all that kind of stuff that we do about the data, it comes under the category of perception. And once we have that information in place, then we can do something from that data that comes into the category of prediction. Or probably if I ask you, how do you want to go from point A to point B? You want to actually get the sense of your environment, decide everything, and then you also get a sense of what other entities in the environment are going to be doing, because that actually caters what you are going to do next. So that is where prediction lies. It tries to predict what the other agents in the environment are going to be doing, as in like what should I be actually yielding to the next car in the junction, or should I be yielding to a pedestrian in the crosswalk, or what is going to be the speed of the next vehicle. So all these things come into the category of prediction, and then we come to planning. That is more egocentric. That is basically what you want to do. And that can also be categorized into two parts. I mean, you already have you just put up put location A and location B, and you'll get a whole route. But then it comes to low level planning as well, like what should be the for a car, what should be the acceleration, what should be the steering rate that the car instantaneously had to take, so that's to take a particular decision. And so that is more about the end-to-end driving. Now, if we have to touch base upon how LLMs can drive, probably they are much capable of actually incorporating the world knowledge that they have. They have much more reasoning capabilities incorporated into them, and that's where they can try to plan much easier. But we cannot just simply replace this stack with an LLM without teaching them how to, what kind of actions should they take. It can just give you a high level plan. Okay, if you want to go from San Francisco to Sunnyvale, okay, this you can take this route, but it cannot give you the low level actions, or basically what should be the instantaneous acceleration or steering rate that you have to take in order to go from San Francisco to Sunnyvale. We can talk about that more, but I mean, I think so that caters a little bit of that question.
Yeah. I mean, so I guess if you think about simulation, it's a pretty big word. And so I got to luckily work on a bunch of different parts of it. But ultimately, what it comes down to is you're taking the car's like brain and you plop it down into this fake world and see what it does. And then you try to evaluate it afterwards and either make a bunch of observations or tell it did something good or bad, right? And so maps and all of the other data, that all feeds into the system, right? And so the more of that that just shows up there nice and pretty and like formatted greatly, means that the simulation is going to be a lot easier to run. It's going to be cheaper to run. It's going to be more predictable. It's going to be a lot easier for me to simulate things. The like less and less and more ambiguity that it gets added in, it makes it more expensive and harder and trickier and almost less like the real world. So I think you're constantly trying to like strike a balance between those two, and really nice maps really help out and make it a lot easier to simulate things. So I think like from a cost perspective, it'd be nice to just not have to have maps for different reasons. But if you can have maps and they're going to make the car perform better and be safer and make a lot of other things easier and cheaper in some ways, then usually it's worth it. So everybody's got different opinions on that, though. So it just kind of depends on where you land.
Yeah, so I guess after all the experts are working on their portion of their project, it's being fed over to the planning division. So for people like me, when we were in our positions, we would be, from what Simon actually mentioned, localization is extremely crucial, important before we can even get started, especially at Zoox. We had to make sure everything was localized, everything was actually grounded to the correct centimeters, everything. From there, we would be testing and making sure that we are collecting the correct data. And sometimes, for Zoox specifically, we would try to collect unique data, such as San Francisco, people walk their cats and ducks and everything. We catch that, definitely catch it, just so we can add that to the system. But if there were any errors, we would return it back to one of the teams, let them know what was going on with the issue, and then those teams would continue to reprocess it, make it better, and then send it back to us and continue testing.
Yeah, could you talk more about like what kind of tests happen before you know a car is ready for the road? Do we just let any car on the road willy-nilly, or do we have like some strict standards that a car has to comply by before it's out in public in front of people and pedestrians?
So for us, whenever we went to a new location for Zoox, we have multiple locations. I think we just opened up in LA, but we had Vegas was a big operation, trying to mainly test more warmer climate, and on top of that, Seattle was one to test for rain activity, how well the vehicles would operate and handle. Wait, could you say one more time for the question?
Yeah, what are the tests that go before you know a vehicle is like ready for the road?
So it'd be a lot of testing. We have hundreds of vehicles, and all over the country we have workers just operating in all different climates. Once we collect it, we try to actually, I guess, process what's important, what's not as important. And once we determine it's safe-wise, that's a lot of just having dummy figures. Say for one, we do accelerated braking procedures, where we can have an occlusion zone somewhere where it's a blind spot, have the car go at a set speed, say 40 miles an hour, and then have this fake figurine just walk out on the road and see how quickly the autonomy can slam the brakes to make sure nobody gets injured. Once it hits all these certain criteria, it's actually safe, we'll put it onto the road for testing. And then, even then, it's a very small routes, just usually around the Zoox San Francisco headquarters. And if it meets those safety procedures, we start to expand it to other areas of San Francisco.
Thank you. That kind of ties into debate that the AV industry has, which is LiDAR or no LiDAR. We all know, like, Tesla is very no LiDAR. We want to be cool. We don't want that expensive thing on the top of our car. And then there's Waymo, obviously, and Zoox also use LiDAR. So, Kobi, do you want to start us off on that?
Yeah, so this is kind of a hot topic in like the AV world. Everybody's got 2 cents, and yeah, everybody's kind of gets the concept of lasers and kind of gets the concept of cameras, and so it kind of leads to a lot of opinions. And some people are definitely experts, and some people aren't. I wouldn't say that I'm necessarily an expert, but in my personal opinion, cameras have a lot of like data basically in them, and if you can get that data out of it in a nice way, quickly, and interpret it really well, it will do a good job. But I think the hard part is like extracting all of the right data and knowing what to throw away, because there's tons of points in that picture that just don't matter at all. And so I have a hard time letting go of the idea of lasers being an essential piece to driving, just because there's a lot of like really nice benefits. There's also a lot of like cons, but I think the benefits outweigh the cons. Like day or night doesn't matter really. If there's laser shining with a camera, you have to have different cameras for day and night, like all these different things. Lasers have fewer data points, but every data point has like X, Y, Z, and like brightness. So there's a lot more information that's like usable in each point. There's fewer of them, but you get more like substance out of it, I guess. And so you don't have to throw away as much when you're like talking about lasers versus cameras. But that's kind of like I said, it's kind of a hot topic. But there's also like definitely drawbacks. Like most lasers spin around, right? And more things that move, more things can go wrong. So there's all sorts of different reasons, I guess. And so it kind of depends on a little bit of like where compute ends up and how much we invest into different forms of sensing, I guess.
Anyone want to add anything to it?
I mean, what I personally believe is, I mean, so the more capabilities you have, the better you will be able to learn a particular, like let's say in the self-driving domain, you will be able to better learn driving. So I think so addition of a LiDAR or any other sensor per se adds to the capability, and probably it also have like lesser and less, probably relatively lesser data, or probably lesser technology to, I mean, yeah, we might need some processing for the LiDAR data, and then we probably need some algorithms to process that as well. But just to be solely relying on one modality of data probably requires a lot more, engineering efforts in order to be a bit more, I would say, capable in different situations and different environments. Probably every sensor modality has its own advantages in different situations. So if a particular product is looking for more robust autonomy, probably the better hyper redundant capabilities that a particular product has, it might help. But yeah, I mean, there can be viewpoints that might differ from that as well. But I mean, this is what I think. And can be applied to, I mean, humans as well. I mean, the more capable you are, you probably are better able to perform particular task in certain situations.
I kind of want to add on to that a little bit. So you talk about performing better and making better decisions, but then I'm curious what counts as a right decision, like especially when there's like an accident about to happen. Like how would a self-driving car solve the trolley problem? Would it prefer killing one person over five, or like how does that? Who decides that? Anyone can take it, but yeah. Do you have any thoughts on that?
Sure, thanks. I mean, what is right actually is a dilemma for human beings as well. I mean, it totally depends upon certain situations. So, like what a self-driving car could do in a particular situation, it totally depends what it has been trained to do. It totally depends upon the preferences, and the preferences are injected by humans again. So it again comes back to what is right as per the humans, because the current stack that the AVs have don't at least that are driving don't have any capabilities of reasoning out. So the one of the major capabilities of humans are like intuitive decision making as well. So deciding what is right can probably can be injected into the self-driving stack as some kind of, like in our LLM domain, there is another post-training method that is now very popular of preference-based learning, or probably having aligning the language models to generate outputs that humans would prefer actually most of the times. So injecting those, but that could be again right in certain situations, uh, and maybe preferred by a certain set of humans or certain set of groups, and might not be liked or preferred by another set of groups, and that's again like human versus human, not human versus self-driving car.
Well, I'd just like to add that in order to make an accurate decision or complicated decision, you will need accurate data. So it kind of goes back to LiDAR versus camera. So if you don't know where the distance this person is or the object is, how are you going to make that decision accurately? Yes, of course, you can do that with AI algorithms to calculate the distance just purely using camera. But yes, there's a lot of guesswork. This is not 100%. LiDAR, on the other hand, gives you a lot of certainty. A lot. It's centimeter accuracy. It's pretty much everything that they see is very, very accurate. So, you know, I would definitely prefer LiDAR if I ever own a AV. But yeah, if I can afford it.
And now that we're talking about making the right decisions and making sure no accidents happen, I'm actually curious if you could talk about, Tariq, about your work when things do go wrong. Like, let's say an accident happens, who's responsible for that? How does it travel up the chain of command? And like, what are the what are the what are the changes that the company makes to make sure that it doesn't happen again?
So for Zoox, they do make a lot of changes when it comes to necessary. Usually, it's going to be responsible, as in my experience. Oh yeah, sorry. From what I witnessed, it'll be usually up to the driver and the software tester. So for Zoox specifically, they will usually have one autonomy driver. This person would be dedicated to have their hands 9 to 3, just pretending to be driving. If anything occurs with the vehicle, they take the wheel and they drive what we call manual, just to make sure it's all human driven after that. The software tester has to make sure to be doing what we call call-outs, making sure that everything's being read from the LiDARs, radars, sensors, and cameras is being properly coordinated on the screen. If anything does happen, say a crash happens, I believe we would consider it urgent triage to say if it was something that could have been lethal, or if it was lethal, we would have setups to get in contact with the police, get in contact with paramedics, make sure that the person who was in the crash, it was safe, that they were okay. Getting photos of all angles of the vehicles. This is one factor to protect Zoox as a company. But from my experience, if anything was to occur, there would be an internal investigation to find out if this was at the driver's fault, if this was the public's fault, if it was the software tester's fault, or if it was directly the software. If it was directly the software, that would be going up to middle management or higher up management, and they would have to do internal investigations to see more into the software itself.
Does anyone want to add anything? We can move on. Okay.
Yeah, I'm pretty sure everyone's aware where the fallout, where the crews went over a pedestrian and dragged that person like 20 feet and so on and so forth. I wasn't there at Cruise, but I was with another company, and that fallout actually shook the entire industry. And everybody took measurement, I assume. But what I can speak for is, first, we need to identify what is accident and what is not an accident. And we wanted to do everything we can to prevent that accident from happening in the first place. That's the first step we take. And 90% of times is that the accident happened is the third party who went into the RV rather than RV run into the person. And when it does happen, and we will make sure that this is confirmed accident, not some false readings, false positive event. And there's a lot you can do in localization because when someone or something hit a car, went into a vehicle, there's a certain very distinctive signals that we can detect, and we can make sure that first this is an accident, okay, and then what to do with this accident. Normally, a machine is not good making decision like this, so we hand it over to a human being. That's what we call a RVA team, remote vehicle assistant team, and this is being handled by a human being behind a computer screen and monitoring all those AV currently taking place within city limits or a region and so on and so forth. Once that alert is being sounded, and this human being would quickly reveal all the footage or the confirmation by the whatever the module, and they would confirm, oh yes, this is an accident. We need to notify the police. We notify the passenger. We need to talk to the passenger. We need to send teams to the location. Then a human being can easily handle, I don't know, whatever the events AI can come up with. And this is something that we have done a lot of research into and taking almost every measure that we can to prevent accident. But the reason why it's called accident is something we cannot prevent. That's why we call it an accident. And when it does happen, that's something that we can do about it. And I believe a human being can easily handle whatever the issue is, rather than a AI model or whatever the computer can come up with.
I have a follow-up. So you've worked at a lot of different companies. You worked at Toyota Research Institute, then you were at Cruise, now you're at Motional. Do you think there was a change in cultures that you could see distinctly that might have led to what happened at Cruise, or that might be different at the other companies? Like, do you think the culture kind of impacts that? Because you cannot make any bad decisions or cannot move too fast in this industry, because if you move too fast, people might die, and that's a big cost.
Yes, I do agree with that. If you go too fast, expand too fast like Cruise did, I'm not saying it is their fault or anything, but yes, if I were making that decision, I would definitely slow down a little bit. Review it, some of the corner cases, special cases, a lot more thoroughly before I expanded to a dozen more cities. Yes, Cruise got a very fast-paced culture. Everything they do is fast, and whenever they encounter problems, they either throw money, resource, and all of the above onto their problem until their problem is solved, which is in pros and cons, right? So you are solving this problem, but have you considered 99 other problems that you are not solving, and just putting a bandage on it or turning your head the other way, it doesn't mean the problem will go away. So Cruise have this very unique culture, but two other companies that I work for, they are a lot more safety oriented, and they would do testing over testing over testing and make sure all the study is being done, all the corner cases is being covered. Using Toyota, for example, say what you want about the company, they maybe move a little bit slower than the Cruise or any other tech company, but they are very, very safe. And whenever they find a problem, the safety related, anyone can stop production. They can just sound the alarm out, everything stop. But whereas the other two companies that I work for, what you get is a trigger of evaluation. That's it. Nothing stops just yet until they are confirmed this is a safety issue. But Toyota, safety issue, that's it. You're done for the day. You need to be reviewed. You need to slow down. You need to look at yourself in the mirror and figure out what's going on. And then we resume afterward. And we only resume when we are safe.
Yeah, actually, even from my own experience at Zoox, safety was a major concern. Even for what Sam was mentioning when it came to Cruise, that was a great learning lesson for the company. Once it happened the very next morning, we all had a team meeting, and it was really going into what was going on with the crew situation, what Zoox needed to do to make sure that we stay safe, and mainly just to avoid lawsuit. So yeah.
Thank you for that. I have second last question to Kobe. We talk about making sure that mistakes don't happen. What do you think? There's any simulation, any scenarios that are really hard to simulate, or some things that you can't be prepared for that might lead to accidents? Or are there some instances that just the car needs to be on the road in order to be able to deal with that?
I guess it's kind of a little bit of a cop-out answer, but both. I guess you can't simulate stuff that you don't know to some extent. And so that's why real driving is really nice, is it's a lot of good data about real life cases. But that said, you obviously don't explore every edge case, and you have to drive many, many miles to find all these things. And so there's again pros and cons, and you have to do it in the right way, right? Like you can't just set the car free and see what happens. But then on the flip side, simulation is kind of only as real as the inputs, and so it's pretty hard to simulate the whole world. That's the problem that companies, that's all they do is try to simulate the whole world. And so yeah, it's kind of it's not an all or nothing sort of problem, and it's kind of a balancing act, and it really kind of depends on what you're trying to test. Certain things are going to be stuff that you can't explore when you're just driving around the world, and you'll never run into unless you drive an infinite amount of miles. And so that's where you want to lean super heavily on trying to come up with a nice simulator that allows you to find those things. But you can't spend all day, every day working on just simulation, because then you'll never have this car that drives around. So again, it's a bit of a cop-out answer, but you got to have both, and you can't have one without the other, I guess.
Thank you. Does anyone want to add something?
Even if we have the simulation and we have been testing certain scenarios or n number of scenarios, there is always a sim to reality gap that is there, and we might not be able to cater most of, or maybe simulation is as better as the data that has been used to create the simulation. So if we have not catered enough situations or scenarios, that probably the vehicle might be tested in real life, we might not be able to test those anyways, and we should not be expecting that the vehicle should actually perform well in those certain scenarios as well. So it's all about the fidelity of the simulator, how much information are we capturing in the overall or different certain scenarios that we are capturing in that simulation, and how easily that can be translated to real life. Considering all the physics, all the dynamics, not necessarily we can have a very perfect simulator, and maybe I can go a little bit technical. If we have to, let's say, in a simulator, if I want to get to the next state, probably I need to do some kind of kinematic equations to get to the next state based on a certain action. But in real life, there are n number of factors actually that can decide what the next state of the vehicle could be. So again, there is going to be a gap from the simulation to reality, and we have to account for that limit of uncertainty that could be there.
Yeah, thank you so much. I have one final question. You guys can kind of go around, but a lot of us are students, or a lot of us are graduating soon and are looking for jobs. So what are your best tips for students? And I know, Simon, you've hired more than 50 people in your career. What is something you look out for? Some of you have had more straightforward career paths, like Kobe, who was just at Google forever. Some of you not so much. So what are some of your best advice or pieces for students or people graduating soon?
Thank you. So I think when I look at a candidate, I look for main categories. One is flexibility, adaptabilities, experience, and as well as subject matter expertise. Look at those four things. It depends on the roles, seniority, and I will look at the combination of those four categories. And where with the right combinations on this particular role and seniorities, I would be very excited for you. But again, this is a very general kind of type of answer. You cannot be perfect in every single role, every single category in every single role. And my advice to you is just to be specific, be good at what you do. Focus on that. That's your strength. And you don't have to be a generalist. You don't necessarily have to be a generalist. My entire career is focused on mapping and localization. And I think I cannot call myself an expert, but I know a thing or two about that.
Yeah, actually, so for me, how I got my position at Zoox was just through friends. Did a lot of networking, met one of the branch managers at Vegas. Lucky enough for me, he became the branch manager at the time. We just met twice. But I guess one way I can return it back is it was a contract role when I was starting. But if there's any students who are interested in autonomy, I believe Zoox is still doing contract roles. They've grown it much larger to various multiple different testing teams. That's my name on LinkedIn. Just give me a contact, and then I'll try and help out and network with whoever I know is still at the company. But it's a great opportunity. I would say anyone that's has that drive, has a real core belief and interest in this field should really pursue it. And if there's anything I can do to help out, just let me know.
Yeah, thank you. Is that all? Do you have anything?
I mean, I would like to emphasize on one of the points that Simon mentioned, that you have to be good at your basics, irrespective. I think so. There could be a diversity of different, domains that in terms of what people are interested in. Maybe people are interested in core mechanical engineering or maybe software engineering, and even if or maybe in core CS they could be related. I mean, they could be interested in maybe AI and robotics, and even if in AI robotics could be interested in either of those categories that were mentioned, perception, planning, or prediction. So, but irrespective of that, I think so. What everyone looks for is, how good are you at your basics? It totally depends upon the seniority level. I mean, they can expect more from you based on if they are hiring for a senior position, how much of an expert are you at a particular domain. But if you just stick to your basics, know all of, if you're able to explain things in a well-defined way, that's all counts. I mean, let's say if you are interested in AI and robotics, probably a good thing to have is good mathematics skills. Not the mathematics that we were taught in 10th standard. It's more about statistics, probability, calculus. All these things are actually overlapping in any set of domains. Probably even if you are going for maybe electrical engineering jobs or mechanical engineering, so good mathematical skills. And I think so autonomy is everywhere. So even if you are interested in simulation, mechanical, electrical, computer science, it's a nice thing to actually be good at least one programming language. Have a good command over that, Python, C++, whatever that you are interested in or whatever the role requires. That is an important aspect to showcase your skills and to actually learn a little bit more faster. And that's what people are also looking for in at least in AV industry. So I mean, this answer is more specifically to AV industry, but I mean it can be generalized to other industries as well. So, and yeah, feel free to reach out to any one of us based on the roles that you're interested in, and I can actually take things offline as well if people have very specific questions about the hiring requirements.
Yeah, I think I'll just add a little bit in there. So like one thing that I feel like I experienced in my time working, I guess, is even if you're the smartest person in the world, like if you're a pain in the butt to work with, like I don't want to work with you. Like I would much rather work with someone who's like a kind person, who's like easy to talk to and like nice to work with. And I'm gonna get so much more done if I'm surrounded by people who are like actually real human beings who are like nice and want like everybody else to do well as well. And so I think that you got to kind of remember that like everybody is actually like people. And so when you're coming at these jobs, it's not just like a robotic thing. It's going to be a lot of like, I don't know, how nice are you to work with, and like how much do you actually care about solving problems and that sort of thing. And I think that goes a long ways because I'm definitely not the best at anything that I've ever worked on at all, but I will try my hardest, and I'm gonna at least like listen to people too, you know. And so I think that that goes a lot further than a lot of people think when it comes to like getting jobs and stuff. And it also just makes like work so much more enjoyable if you work with nice people too.
Yeah, I totally agree. I want to expand a little bit on flexibility and adaptability, so and what that really means. Flexible is being, you know, you in a way that you can be a people person, in a way you can be technical, and let's say you were hired for a software engineering job, but you might ask to do some firmware stuff, and that means that you have to quickly adapt to that role, rather than I'm just a software engineer. I can't not work on that, and that's definitely not someone that are able to last very long in a corporate environment. So I'm not telling you to be a jack of all trades, but whenever necessary, you need to adapt and be flexible to adapt to your current role and environment. So,
Okay, I think that's all the questions I have for you guys. And if you know anything about me, you know I do everything at the 11th hour. So I reached out to these people, you know, very and they all agreed to come and talk to all of you. So I'm really thankful for their time, and I really appreciate it. Thank you so much for making this such a nice event.